What could make German military engineers, men who had designed some of the most sophisticated weapons of World War II, look at a simple American rifle with something approaching dread? In the laboratories and testing facilities where captured Allied weapons were analyzed, German ordnance experts found themselves confronting a troubling reality. The weapon in question wasn't the famous M1 Garand rifle that had earned grudging respect from Wehrmacht soldiers. It wasn't the Thompson submachine gun that Hollywood had made iconic. It was a carbine, a lightweight rifle that American doctrine classified as a defensive weapon for support troops, something that shouldn't have posed a significant tactical threat. Yet as German engineers disassembled, tested, and analyzed the M1 Carbine, they began to understand why their troops were reporting increasingly desperate engagements against American forces equipped with this unassuming weapon. The M1 Carbine represented something that challenged fundamental assumptions about infantry weapons and tactical doctrine. To German eyes, trained in a military tradition that emphasized the bolt-action rifle as the foundation of infantry firepower, the carbine seemed almost frivolous, too light, too small, firing a cartridge that appeared inadequate for serious military use. German infantry doctrine centered on the squad machine gun as the primary source of firepower, with riflemen serving supporting roles. The American approach, which distributed semi-automatic capability widely throughout units and equipped even support personnel with weapons capable of rapid aimed fire, represented a fundamentally different philosophy. As the war progressed and German forces faced American troops in North Africa, Italy, France, and finally Germany itself, reports from the front began painting a concerning picture. American units demonstrated rates of fire that German formations struggled to match. Officers, radio operators, drivers, cooks, clerks, personnel who in German units would have carried pistols or bolt-action rifles if they were armed at all, were engaging German soldiers with semi-automatic carbines at ranges and with volume of fire that disrupted attacks and complicated defensive operations. More troubling still, the carbine's light weight and handy characteristics meant that American troops carried it everywhere, maintaining armed capability in situations where German soldiers might have left their weapons behind. German engineers, examining captured carbines and studying tactical reports, began to grasp the implications. The M1 Carbine wasn't designed to replace the infantry rifle or compete with machine guns. It filled a niche that German doctrine didn't really acknowledge, providing genuine combat capability to soldiers whose primary roles were support functions, but who might find themselves in combat situations. The weapon's semi-automatic fire, lightweight, manageable recoil, and adequate range created a combination that proved devastatingly effective in practice, even though it violated traditional thinking about what a military rifle should be. The Americans had created not a better rifle, but a different category of weapon, and in doing so had given themselves advantages that German forces, bound by conventional thinking and increasingly constrained resources, found difficult to counter. The M1 Carbine's development began in 1940, driven by recognition that the standard M1 Garand rifle, while excellent for infantry combat, was too large and heavy for many military roles. Artillery crews, mortar teams, radio operators, vehicle drivers, officers, and various support personnel needed weapons for self-defense, but the nearly 10-pound Garand with its powerful .30-06 cartridge was impractical for soldiers whose primary duties didn't involve infantry combat. The existing alternative, the M1911 pistol, provided inadequate range and firepower. The Army wanted something between a pistol and a rifle, a lightweight, easy-to-handle weapon that provided better range and accuracy than a pistol, but didn't burden soldiers whose hands needed to be free for other tasks. The specifications were demanding. The weapon needed to weigh less than 5 pounds, fire semi-automatically, use a cartridge more powerful than pistol ammunition, but less than rifle ammunition, and be reliable under field conditions. Multiple manufacturers submitted designs in a remarkably compressed development program. Winchester's design, submitted by David Marshall Williams and other engineers, won the competition. The weapon entered production in 1941, and by the time of Pearl Harbor, the first carbines were reaching troops. The .30 carbine cartridge developed for the weapon represented a compromise between competing requirements. More powerful than pistol rounds, it fired a 110-grain bullet at approximately 1,890 feet per second from the carbine's 18-inch barrel. This gave effective range of about 300 yards, far exceeding pistol capability, while remaining manageable in the lightweight carbine. The cartridge generated significantly less recoil than the .30-06 used in the Garand, making the weapon controllable in rapid fire even for soldiers with limited training or smaller stature. The carbine itself was remarkably light at 5.2 pounds empty, less than half the weight of the Garand. Its compact dimensions made it easy to carry and maneuver in vehicles, in buildings, and in wooded terrain. The action, using a short-stroke gas piston system, proved reliable and required minimal maintenance. The weapon fed from detachable box magazines holding 15 rounds, later increased to 30 rounds with improved magazine designs. This magazine capacity, combined with semi-automatic fire, gave carbine-armed troops firepower advantages over soldiers with bolt-action rifles. Production scaled rapidly to meet enormous demand. By war's end, over 6 million carbines had been manufactured, making it the most produced American small arm of World War II. Multiple contractors produced the weapon, with Winchester, Inland Division of General Motors, and others delivering hundreds of thousands of units. The carbine was issued far more widely than originally planned, eventually arming not just support troops, but significant numbers of infantry, paratroopers, and other combat personnel who appreciated its lightweight and handiness. German forces first encountered the M1 Carbine in significant numbers in North Africa in 1943. Initial reactions were mixed. The weapon's light report and smaller cartridge led some German soldiers to underestimate it. Veterans familiar with the heavy punch of rifle cartridges sometimes dismissed the carbine as inadequate. However, those who faced sustained fire from carbine-equipped troops quickly revised their assessments. The weapon's semi-automatic capability allowed American troops to deliver volume of fire that surprised Germans expecting the slower rate of bolt-action rifles. The Italian campaign provided extensive testing of the carbine under varied conditions. In mountainous terrain, its lightweight proved advantageous, as soldiers could carry it during long marches without the fatigue imposed by heavier weapons. In urban combat, its compact dimensions made it easier to maneuver through buildings and around vehicles than full-length rifles. Paratroopers particularly favored the carbine, as its lightweight and collapsible stock variant made it practical for airborne operations where every ounce mattered. The Normandy invasion and subsequent campaign across France brought the carbine into even more widespread use. American armored columns included numerous carbine-armed troops, tank crews who could fight as infantry if necessary, vehicle drivers who needed weapons they could store in cramped spaces, officers who needed to command while remaining armed. The weapon's prevalence meant that German forces consistently faced more armed opponents than they would have fighting armies, where support troops carried only pistols or no weapons at all. Urban combat in French and German cities highlighted both the carbine's strengths and limitations. Its semi-automatic fire and handy characteristics made it excellent for close quarters fighting in buildings. However, its lighter cartridge sometimes failed to penetrate the heavy walls and substantial cover that characterized European urban construction. Soldiers learned to aim for openings and use multiple hits rather than expecting single-shot stops through cover. Despite these limitations, the carbine remained popular for urban warfare due to its ease of handling in confined spaces. German military intelligence devoted considerable attention to analyzing the carbine. Captured weapons underwent thorough examination. The simplicity of manufacture impressed German engineers, who were increasingly struggling with resource shortages and production bottlenecks. The carbine's stamped parts, simplified manufacturing processes, and minimal hand-fitting represented approaches to weapons production that German industry, committed to traditional methods emphasizing precision machining, had not fully embraced. The Americans had created a weapon that was good enough rather than perfect, and had done so in quantities that German production couldn't match. Tactical reports from German units facing carbine-armed Americans consistently noted the high volume of fire American troops could deliver. When German squads attacked American positions, they faced not just rifle and machine gun fire, but carbine fire from what seemed like everyone in the American unit. Officers, medics, radio operators all returned fire with semi-automatic weapons. This created a psychological effect beyond the carbine's actual lethality. German soldiers faced a wall of fire that made advancing difficult and dangerous, even when individual hits weren't necessarily fatal. The carbine's role in American tactical doctrine evolved throughout the war. Initially conceived as a defensive weapon for support troops, It increasingly saw employment in offensive operations. Airborne units adopted it widely due to its light weight. Some infantry units armed squad leaders and other key personnel with carbines, recognizing that their need to command and communicate made the lighter weapon more practical than the Garand. Reconnaissance units favored it for its compactness and adequate firepower. This doctrinal flexibility, responding to combat experience rather than rigid preconceptions, maximized the weapon's utility. The psychological dimension of facing carbine-armed troops affected German tactical behavior. Knowing that even American support personnel were armed with effective weapons complicated German planning. Raids on American rear areas became riskier when cooks and clerks could respond with semi-automatic fire. The traditional German practice of infiltration tactics, relying on surprise and close assault, became more dangerous when defenders could immediately return high volumes of fire. The carbine's ubiquity created a defensive depth that German forces found frustrating to penetrate. German engineers examining the carbine recognized several features that represented advanced thinking. The weapon's use of stamped and welded parts instead of traditional machining reduced production time and cost. The design's simplicity meant fewer parts to manufacture and assemble. The sight system, while basic, proved adequate for the weapon's intended range. The safety mechanisms were simple but effective. Every aspect of the design prioritized manufacturability and reliability over refinement, an approach that produced a weapon perfectly suited to industrial mass production. The ammunition logistics demonstrated American industrial capacity, producing billions of rounds of a new cartridge type while maintaining production of existing ammunition types represented a manufacturing achievement that impressed and intimidated German analysts. The Americans could afford to introduce a new cartridge, build production capacity for it, distribute it globally, and keep troops supplied, all while maintaining existing supply chains. German industry, struggling to meet basic production goals for standard ammunition, couldn't have contemplated such an undertaking. The carbine's success influenced German thinking about weapons development. Late-war German programs like the StG-44 assault rifle reflected recognition that light, handy, semi-automatic or automatic weapons firing intermediate cartridges offered tactical advantages. However, German development came too late and produced too few weapons to significantly affect outcomes. The Americans had fielded their intermediate weapon years earlier and in millions of units, gaining advantages that German forces couldn't overcome. The broader strategic implications concerned German military planners. The carbine represented not just a weapon, but a symptom of American advantages across multiple domains. The industrial capacity to introduce new weapons while maintaining existing production. The logistical capability to distribute and sustain millions of specialized weapons. The tactical flexibility to adapt doctrine to maximize new capabilities. The training infrastructure to familiarize millions of soldiers with new weapons. These systemic advantages, exemplified by but extending beyond the carbine, created cumulative superiority that Germany couldn't match. The M1 Carbine's origins lay in a 1938 study that identified inadequacies in existing weapons for support troops. The M1911 pistol, standard issue for officers and specialists, provided minimal effective range and limited stopping power. The M1 Garand rifle, while excellent for infantry, was too heavy and cumbersome for soldiers whose primary duties were non-combat roles. The study recommended developing a light rifle that would give support personnel effective defensive capability without the burden of a full-power rifle. Development accelerated with the approach of American entry into World War II. In 1940, the Army issued specifications for what was initially called a light rifle. The requirements were specific: weight under 5 pounds, semi-automatic operation, effective range of 300 yards, caliber approximately 30, and simple enough for mass production. The compressed timeline demanded rapid development, with manufacturers given only months to design, prototype, and test their submissions. Winchester Repeating Arms, one of America's most prestigious firearms manufacturers, assembled a team including David Marshall Williams, a brilliant but troubled designer who had developed the short-stroke gas piston system while serving time in prison for murder. Williams's gas system, which used a small piston driven by gas tapped from the barrel, provided the operating mechanism for Winchester's carbine design. The system was compact, reliable, and generated minimal recoil, making it ideal for a light rifle. Williams's background added fascinating dimension to the carbine's development story. After killing a deputy sheriff during a raid on his illegal whiskey still in 1921, Williams was sentenced to 30 years, but served only 8 before being paroled. During his imprisonment, he had been allowed to work in the prison blacksmith shop, where he developed firearms designs including the short-stroke piston system. His technical genius, despite his criminal past, made him invaluable to Winchester's carbine development effort. The irony of a convicted murderer designing a weapon that would arm millions didn't escape those familiar with his story. The Winchester design faced competition from numerous other manufacturers, each presenting their interpretation of the requirements. Testing in late 1940 revealed that Winchester's submission offered the best combination of lightweight, reliability, and ease of manufacture. The Army officially adopted the weapon as the U.S. Carbine Caliber 30 M1 in September 1941. Production began immediately, with Winchester's Connecticut factory retooled to manufacture the new weapon. Production demands quickly exceeded Winchester's capacity. The Army anticipated needing hundreds of thousands of carbines, far more than a single factory could produce. Inland Manufacturing Division of General Motors, which had never manufactured firearms, was contracted to produce carbines at a new facility in Dayton, Ohio. Additional contractors soon joined the program, including IBM, Rockola, Quality Hardware, National Postal Meter, Standard Products, Underwood, and others. This diversification of production sources ensured that production bottlenecks at one facility wouldn't constrain overall output. The diversity of contractors reflected American manufacturing flexibility that impressed and intimidated German observers. That an office equipment manufacturer like IBM or a jukebox company like Rockola could successfully produce military rifles demonstrated organizational and technical capabilities that German industry struggled to match. The Americans had created production systems that could rapidly repurpose civilian manufacturing capacity for military needs, a flexibility that proved strategically valuable throughout the war. The manufacturing approach emphasized simplicity and interchangeability. Winchester's design used stamped and welded parts instead of extensive machining wherever possible. Tolerances were loose enough that parts from different manufacturers were interchangeable without hand-fitting. This good enough philosophy, accepting minor variations in fit and finish to achieve volume production, represented a shift from traditional American firearms manufacturing that had emphasized precision craftsmanship. The .30 carbine cartridge required developing alongside the weapon. Winchester designed a round that fit between pistol and rifle cartridges in power, using a 110-grain bullet propelled to about 2,000 feet per second. The cartridge case was straight-walled, facilitating extraction and simplifying magazine design. The relatively low pressure compared to rifle cartridges allowed lighter construction of the weapon, contributing to weight savings. Ammunition production ramped up rapidly, with multiple contractors producing hundreds of millions of rounds. The ammunition development involved more technical challenges than initially anticipated. Creating a cartridge that balanced adequate power with controllability in a lightweight weapon required extensive testing. Early loading sometimes produced excessive muzzle flash or inconsistent velocities. Powder formulations needed refinement to ensure reliable cycling across temperature ranges. These challenges were overcome through systematic testing and incremental improvements, demonstrating the thoroughness of American ordnance development processes. Early combat reports from the North African campaign provided the first serious feedback on the carbine's performance. Soldiers appreciated its lightweight and handy characteristics. The semi-automatic fire capability impressed troops accustomed to bolt-action rifles. However, some complaints emerged about the cartridge's stopping power. Reports of enemy soldiers continuing to fight after being hit raised concerns about the round's effectiveness. These concerns would persist throughout the war, though they were partly attributable to unrealistic expectations about what any single shot could achieve. The stopping power controversy reflected deeper questions about terminal ballistics that military forces have struggled with throughout firearms history. The .30 carbine round, with its lightweight bullet and moderate velocity, produced wounds less severe than rifle cartridges, but more serious than pistol rounds. Whether this intermediate level of wounding was adequate depended on context, expectations, and comparison standards. Soldiers accustomed to the devastating effects of the Garand's 30.06 cartridge sometimes found the carbine's performance disappointing, while those comparing it to pistols found it impressively effective. The M1A1 variant, developed for airborne troops, featured a folding metal stock that reduced the weapon's overall length for easier carrying during parachute jumps. This variant became standard issue for American paratroopers, who valued the carbine's lightweight and adequate firepower. The folding stock proved popular enough that many ground troops would have preferred it, but production priorities limited its distribution primarily to airborne units. The folding stock design required engineering that balanced weight, strength, and reliability. The hinge mechanism needed to be robust enough to withstand hard use while remaining light. The stock needed to lock securely in both positions, extended for firing and folded for transport. These requirements were met through careful design that added minimal weight while providing the desired functionality. The M1A1's success demonstrated that thoughtful engineering could adapt the basic carbine design to specialized requirements without compromising its fundamental characteristics. The M2 selective fire variant, introduced late in the war, added full automatic capability. This addressed tactical situations where suppressive fire was needed, but also increased ammunition consumption and complicated production. The M2 saw limited distribution during World War II, but became more common in subsequent conflicts. Its development reflected recognition that soldiers sometimes needed full automatic fire, even though the carbine's lightweight and small cartridge made sustained automatic fire difficult to control. The M2's development involved more than simply adding a selector switch. The weapon's rate of fire needed to be controlled to prevent excessive consumption of ammunition and maintain some degree of controllability. The firing mechanism required strengthening to withstand full automatic stresses. Magazines needed to feed reliably at higher cyclic rates. These modifications required engineering effort that delayed the M2's introduction until late in the war, limiting its impact on combat operations. The 30-round magazine, developed to complement the M2's automatic capability, proved popular even with standard M1 carbines. The increased capacity reduced reloading frequency and provided more sustained firepower. However, the longer magazines were more prone to feed problems if damaged or improperly maintained. Soldiers learned to carefully manage their magazines, marking reliable ones and discarding damaged units. Magazine design represented one of the carbine's few significant weaknesses. The double-stack, single-feed magazine design, while compact, was sensitive to damage and contamination. The magazine lips could be bent easily, causing feeding failures. Dirt or corrosion inside the magazine body could prevent reliable feeding. These issues meant that while the carbine itself was robust and reliable, its effectiveness depended on properly functioning magazines. Soldiers learned to protect and maintain magazines carefully, recognizing them as critical components of the weapon system. Production quality varied among contractors, with some facilities producing more reliable weapons than others. Winchester and Inland carbines generally earned good reputations for reliability. Some smaller contractors produced weapons that required more frequent maintenance or had higher failure rates. The Army's quality control systems caught most serious problems, but some inferior carbines reached troops. Veterans learned to identify manufacturers whose weapons performed better and sometimes traded to obtain preferred versions. The variation in quality among contractors reflected challenges inherent in distributed manufacturing. While standardization ensured parts interchangeability, subtle differences in manufacturing processes, quality control rigor, and worker expertise affected overall weapon quality. Winchester and Inland, as primary contractors with extensive experience, generally achieved better consistency than smaller contractors with less firearms manufacturing background. This variation, while not preventing the carbine from succeeding overall, illustrated that mass production at unprecedented scales inevitably involved some quality compromises. Combat employment expanded beyond original expectations as the war progressed. The carbine armed not just support troops but increasingly saw use by combat personnel. Squad leaders appreciated its lighter weight compared to the Garand, as their need to observe, communicate, and direct fire made the lighter weapon more practical. Vehicle crews found it easier to store and deploy from cramped spaces. Scouts and reconnaissance troops valued its compactness. This organic expansion of roles reflected the weapon's practical utility, exceeding its official doctrine. The Italian campaign tested the carbine extensively in mountainous terrain. Its lightweight proved particularly valuable during extended movements at altitude, where every pound mattered. In the difficult terrain of the Italian mountains, soldiers often covered long distances on foot, and the carbine's reduced burden compared to the Garand was significant. The weapon's adequate accuracy at the ranges typical of mountain fighting made it effective despite the lighter cartridge. Urban fighting in Italian cities revealed both strengths and limitations. The carbine excelled in building clearing operations, where its compact size and rapid fire proved valuable. However, its cartridge sometimes failed to penetrate the thick masonry walls common in European construction. Soldiers learned that the carbine worked best when they could fire through openings like windows and doors, rather than attempting to shoot through walls. This tactical adaptation maximized the weapon's effectiveness within its limitations. The Battle for Monte Cassino illustrated both the carbine's utility and its limitations. In the monastery's ruins, close-quarters fighting favored the carbine's handiness and rapid fire. However, when engaging Germans occupying stone positions at distance, the carbine's range and penetration limitations became apparent. Soldiers in these situations often wished for rifles with more power and range, even though the carbine's lighter weight had been advantageous during the approach. The Normandy invasion saw massive employment of carbines. Airborne units dropping behind German lines carried them extensively due to weight considerations. The famous defense of Stemmer-Église and other airborne actions featured carbine-armed paratroopers fighting off German counterattacks. The weapon's reliability in the demanding conditions of airborne operations, parachute drops, water immersion, hard use with minimal maintenance, validated the design's robustness. One particularly notable incident involved Lieutenant Richard Winters of the 101st Airborne, who used his carbine during the assault on German artillery positions at Brécourt Manor on D-Day. Though Winters was an exceptional soldier whose success owed more to tactics and leadership than his weapon, the carbine's lightweight and rapid fire served him well during the action. The engagement demonstrated that in skilled hands and appropriate situations, the carbine could be devastatingly effective despite its modest cartridge. The campaign across France showcased the carbine in mobile warfare. Armored columns included numerous carbine-armed personnel who could provide security and fight as infantry if necessary. The weapon's easy storage in vehicles and quick deployment made it practical for mechanized operations. Tank crews particularly appreciated having weapons they could actually use effectively outside their vehicles, unlike the awkward grease-gun submachine guns that were officially issued but often disliked. The Battle of the Bulge tested the carbine under severe winter conditions. Extreme cold sometimes caused functioning problems with various weapons, and the carbine was no exception. However, soldiers who maintained their weapons properly generally kept them functioning. The weapon's simple design meant that field expedients could often address problems, and parts from damaged weapons could repair others. The carbine's lightweight proved advantageous during the rapid movements that characterized the battle. At Bastogne, surrounded American forces included numerous carbine-armed troops. Artillerymen defending their positions with carbines contributed to the perimeter defense. Support personnel armed with carbines augmented the infantry manning the defensive line. The weapon's ubiquity meant that the defenders could maintain a high volume of fire even when casualties reduced the number of infantrymen with rifles. This defensive depth helped the garrison hold until relieved. The final campaigns into Germany saw the carbine employed in all its various roles. By this stage of the war, American forces had refined their tactics to maximize the weapon's effectiveness while minimizing exposure to its limitations. The massive numerical advantage in carbines, millions in service compared to any potential German equivalent, meant that American forces enjoyed firepower superiority from support personnel that German forces simply couldn't match. The crossing of the Rhine illustrated the carbine's versatility. During the assault crossing, boat crews and engineers carried carbines that provided defensive capability without the burden of rifles. Once bridgeheads were established, support troops moving forward with carbines could defend themselves and supplement infantry if necessary. Throughout the advance into Germany, the weapon continued demonstrating its value in the roles for which it had been designed, while also proving useful in roles that original planners hadn't fully anticipated. The M1 Carbine embodied several themes that extended beyond its role as simply another weapon in the American arsenal. Understanding these concepts provides insight into its significance and the concerns it generated among German engineers. The concept of good enough engineering challenged traditional thinking about weapons design. German military culture emphasized precision, craftsmanship, and performance excellence. Weapons were engineered to tight tolerances, carefully finished, and designed to achieve maximum capabilities. The M1 Carbine represented a different philosophy. It was designed to be adequate rather than excellent, prioritizing mass production over perfection. German engineers examining captured carbines found finish work that would have been unacceptable by German standards: rough stamping, visible tool marks, loose tolerances. Yet the weapons functioned reliably, and the Americans had produced millions of them, while German factories struggled to meet production quotas for more traditionally manufactured weapons. This good enough approach reflected American industrial culture, which emphasized volume production, interchangeable parts, and acceptance of minor quality variations if overall functionality remained acceptable. German engineers, trained to admire precision, found this approach unsettling because it worked. The carbine proved that weapons didn't need to be manufactured to exacting standards to be effective, that loose tolerances could actually facilitate production without sacrificing reliability. This challenged assumptions about what was necessary in weapons manufacturing. The philosophical implications extended beyond manufacturing to military culture more broadly. German military tradition valued excellence, discipline, and perfection in execution. The American approach, more pragmatic and less idealistic, accepted that good enough often sufficed when delivered at scale with proper support. This cultural difference in acceptable standards affected everything from weapons design to tactical doctrine, with Americans generally willing to accept adequate solutions that worked reliably over excellent solutions that might work better but required more resources or expertise. The democratization of firepower represented another significant theme. Traditional military doctrine concentrated firepower in specialized weapons and units. German doctrine centered on the squad machine gun, with riflemen providing supporting fire. American doctrine, enabled partly by the carbine, distributed capable weapons throughout units. Support personnel, who in most armies would carry pistols or no weapons, had carbines that provided genuine combat capability. This created tactical advantages that German forces struggled to counter, as American units maintained effective firepower even when primary combat elements were suppressed or depleted. This democratization extended to training and doctrine. The carbine's light recoil and simple operation meant that soldiers with minimal training could use it effectively. Support troops who received limited weapons training could still employ the carbine adequately for defensive purposes. This lowered the threshold for maintaining armed capability throughout units, creating depth of defensive capability that frustrated German infiltration tactics that relied on exploiting rear areas defended primarily by unarmed personnel. The implications for military organization were profound. German forces were organized around the assumption that combat power resided primarily in infantry units and their supporting arms. Support elements were just that. Support not expected to contribute significantly to firepower. American organization, with widespread distribution of carbines, blurred the distinction between combat and support personnel. Everyone could fight if necessary, creating resilience that complicated German tactical calculations. The intermediate cartridge concept, though not fully developed with the carbine, represented important evolution in thinking about infantry weapons. The .30 carbine round, while not truly an intermediate cartridge in the later sense, occupied space between pistol and rifle cartridges. It demonstrated that full-power rifle cartridges weren't necessary for many combat situations, that lighter rounds with less recoil could be effective at typical engagement ranges. This thinking would culminate in assault rifles, firing true intermediate cartridges, but the carbine pioneered the concept that more manageable cartridges could provide adequate performance while enabling lighter weapons and higher ammunition capacity. German engineers analyzing the carbine recognized this significance. Their own development efforts, particularly the STG-44, reflected similar thinking. However, the Americans had fielded their intermediate weapon years earlier and in vastly greater numbers. By the time German assault rifles reached significant production, American carbines had armed millions of troops, providing advantages that German forces could not overcome. The timing advantage represented strategic benefit that tactical excellence couldn't offset. The relationship between weapon characteristics and tactical employment demonstrated how technology enables doctrine. The carbine's lightweight and compact size encouraged its employment in roles that heavier weapons couldn't fill effectively. Airborne operations became more feasible when soldiers could jump with 5-pound carbines instead of 9-pound Garands. Armored operations gained flexibility when vehicle crews carried weapons they could actually use effectively. The weapon's characteristics enabled tactical approaches that wouldn't have been practical with traditional rifles. This enabling relationship worked both ways. American willingness to distribute carbines widely and employ them flexibly maximized the weapon's utility. German doctrine, more rigid and specialized, might not have exploited the carbine's potential as effectively even if German forces had possessed equivalent weapons. The Americans combined technological innovation with doctrinal flexibility, creating synergy that multiplied effectiveness beyond what either factor alone would have provided. The question of whether technology drives doctrine or doctrine demands technology has occupied military theorists for generations. The carbine's case suggests the relationship is reciprocal. The weapon was developed to meet identified doctrinal needs, arming support troops. But once fielded, it enabled doctrinal innovations, employing carbine-armed troops in offensive roles that hadn't been fully anticipated. This iterative relationship between technology and doctrine characterizes military innovation more generally. The industrial capacity theme appeared starkly through carbine production. The Americans introduced a new weapon, developed a new cartridge, built production capacity across multiple contractors, and produced over 6 million weapons while maintaining production of existing weapons systems. German industry, increasingly disrupted by bombing and resource shortages, struggled to maintain production of existing weapons, much less introduce new ones at scale. The carbine represented not just a weapon, but demonstration of industrial capacity that Germany couldn't match. The diversity of contractors producing carbines illustrated American manufacturing flexibility. Companies that had never manufactured firearms, IBM, Rockola, General Motors, successfully produced carbines after relatively brief preparation. This demonstrated organizational and technical capabilities that allowed rapid reallocation of industrial capacity to meet military needs. German industry, more specialized and less flexible, struggled to adapt to changing requirements with comparable speed. The ability to rapidly convert civilian production capacity to military purposes represented strategic capability that affected outcomes across multiple domains. The Americans could surge production of weapons, vehicles, aircraft, ships, and other military equipment by bringing civilian manufacturing capacity online with relatively brief conversion periods. German industry, though technically sophisticated, lacked this flexibility, constraining strategic options throughout the war. The concept of the personal defense weapon, later formalized as a weapons category, originated partly with the carbine's development. Military forces had long struggled with arming personnel whose primary roles weren't combat, but who might face combat situations. The carbine provided more range and accuracy than pistols, but without the burden of full rifles. This created a weapons category that would persist through subsequent decades, with various nations developing their own personal defense weapons for similar roles. German engineers examining the carbine recognized they were seeing a new category of weapon, not simply a scaled-down rifle or scaled-up pistol. The implications concerned them because German forces had no real equivalent. Their support troops carried either pistols, which provided minimal effective capability, or standard rifles, which were often too cumbersome for their actual roles. The Americans had identified and filled a capability gap that German doctrine hadn't adequately addressed. The reliability and simplicity theme ran throughout the carbine's design. Every aspect prioritized function over form, reliability over refinement. The action was simple with few parts. The sights were basic but adequate. The stock was functional rather than beautiful. This design philosophy produced weapons that soldiers could maintain in field conditions with minimal tools and limited technical knowledge. German weapons, often more sophisticated, sometimes required armorer-level maintenance to keep functioning, creating logistical and training burdens that American forces avoided. The simplicity principle reflected American pragmatism about military equipment. Weapons needed to function reliably under adverse conditions, with minimal maintenance by soldiers who were not firearms experts. German weapons, while often impressive from engineering perspectives, sometimes demanded maintenance standards difficult to sustain in combat conditions. The carbine's robust simplicity proved more valuable than sophisticated complexity when reliability under harsh conditions mattered most. The psychological impact of facing carbine-armed troops affected German tactical calculations. Knowing that even American support personnel carried effective weapons complicated planning for raids, infiltration, and attacks on rear areas. The traditional military assumption that rear areas were lightly armed didn't apply when cooks, clerks, and drivers carried semi-automatic carbines. This forced German units to treat American rear areas as more threatening, allocating resources to operations that might have been simpler against forces where support personnel were effectively unarmed. The cumulative psychological effect of facing widespread carbine employment wore down German soldiers over extended campaigns. Constantly facing fire from multiple directions, engaging enemies who seemed universally armed with rapid-fire weapons, created stress and degraded effectiveness. While difficult to quantify precisely, the psychological impact of the carbine's ubiquity contributed to German combat effectiveness declining as the war progressed and American firepower superiority became increasingly apparent. The adaptability and evolution theme appeared in how the carbine developed during the war. The basic M1 spawned variants including the M1A1 with folding stock, the M2 with selective fire, and the M3 with infrared night sighting equipment. Magazine capacity increased from 15 to 30 rounds. These adaptations responded to combat experience and changing tactical requirements, demonstrating organizational flexibility in evolving weapons to meet needs. German weapons development, increasingly constrained by resources and institutional rigidity, struggled to adapt as effectively to changing conditions. The night fighting variant with infrared optics represented particularly advanced thinking. While the technology was primitive by later standards and saw only limited use before war's end, it demonstrated American willingness to explore emerging technologies and field experimental systems. German forces also developed night vision systems, but American industrial capacity allowed more extensive development and production, creating capabilities that German forces struggled to match. The M1 Carbine represented solutions to multiple problems that had plagued military forces historically. Understanding these solutions illuminates the weapon's significance and why German engineers found it concerning. The fundamental problem of arming support personnel received practical solution through the carbine's development. Armies had always struggled with this issue. Support troops needed weapons for self-defense, but equipping them with full infantry rifles imposed burdens that interfered with their primary duties. Pistols provided inadequate range and firepower. The carbine solved this by providing a weapon light enough to not burden support troops significantly, but effective enough to provide genuine combat capability. Artillery crews exemplified the problem. They needed weapons to defend their positions, but spent most of their time operating guns, not fighting as infantry. The M1 Garand, at nearly 10 pounds with its powerful cartridge and significant recoil, was impractical for artillerymen whose primary focus was their pieces. Pistols provided minimal defensive capability. The carbine, at half the Garand's weight and with manageable recoil, gave artillerymen effective weapons they could carry and use without significant interference with their primary duties. The artilleryman's experience illustrated broader issues. During combat operations, artillery positions sometimes came under direct attack. Artillerymen needed to defend themselves and their guns, but their training focused on gunnery, not infantry tactics. The carbine's simple operation and light recoil made it accessible to soldiers whose primary expertise lay elsewhere, enabling effective defense without requiring extensive infantry training. The solution for vehicle crews proved equally valuable. Tank crews, truck drivers, and other vehicle operators needed weapons they could store in cramped spaces and deploy quickly if necessary. The carbine's compact dimensions and light weight made it practical for vehicle storage. Its semi-automatic fire provided adequate firepower for defensive situations or for crews fighting dismounted. This solved the long-standing problem of effectively arming personnel who operated from vehicles but might need to fight outside them. Tank crews particularly benefited from the carbine's characteristics. When tanks were disabled or crews needed to fight dismounted, The carbine provided effective weapons that were far more practical than the submachine guns officially issued to tank crews. The carbine's greater range, compared to submachine guns, proved valuable when crews needed to cover ground returning to friendly lines or defend positions away from their vehicles. Airborne operations received significant benefit from the carbine's light weight. Paratroopers operated under strict weight constraints, as every pound carried during jumps increased risk and fatigue. The carbine allowed airborne troops to carry effective weapons without the burden of full rifles. The M1A1's folding stock further reduced bulk during jumps. This enabled airborne operations with better armed troops than would have been practical with heavier weapons. The paratroopers' unique challenges made the carbine particularly valuable for airborne forces. Jumping from aircraft required carrying all equipment necessary for combat once on the ground. Every ounce mattered, as excessive weight increased injury risk during landing and created fatigue that degraded combat effectiveness. The carbine's light weight allowed paratroopers to carry adequate weapons, plus ammunition, communications equipment, and other essentials without exceeding safe weight limits. The manufacturing solution emphasized volume over precision, enabling rapid production expansion. Winchester's design used stamped parts, welded construction, and loose tolerances that facilitated high-volume production. Multiple contractors could produce carbines with minimal retooling and limited firearms expertise. This approach solved the problem of meeting enormous military demand within compressed timeframes. German manufacturing, committed to precision and traditional methods, couldn't match this production flexibility. The transition from precision craftsmanship to good-enough manufacturing represented philosophical shift in American weapons production. Previous American rifles like the Springfield M1 903 had been manufactured to tight tolerances with extensive hand-fitting. The carbine's approach prioritized volume production, accepting that weapons didn't need to be perfect to be effective. This pragmatic approach proved strategically valuable, delivering millions of adequate weapons rather than thousands of perfect ones. The logistics solution addressed ammunition supply challenges. The .30 carbine cartridge, while requiring introducing a new caliber, was relatively simple to manufacture and lighter than rifle ammunition, reducing transportation burden. The straight-walled case simplified extraction and magazine design. The lower pressure compared to rifle cartridges reduced wear on weapons and simplified metallurgical requirements. These factors facilitated ammunition production at scales necessary to support millions of weapons. The decision to introduce a new cartridge type represented calculated risk. New calibers create logistical complexity, requiring parallel supply chains for different ammunition types. However, the carbine's role as a specialized weapon for specific personnel justified the additional complexity. The cartridge's characteristics enabled the weapon's light weight and manageable recoil, making the logistical burden worthwhile to achieve the desired capabilities. The training solution reflected the weapon's simplicity. Basic carbine operation could be taught quickly, even to personnel with limited weapons training. The light recoil meant that even smaller soldiers or those with limited strength could fire it effectively. The simple manual of arms, load magazine, chamber round, release safety, fire, required minimal instruction. This enabled support troops to achieve adequate proficiency without extensive training that would have interfered with their primary specialties. Training efficiency proved particularly valuable given the rapid expansion of American military forces. Millions of soldiers required weapons training in compressed timeframes. The carbine's simplicity meant that support troops could achieve basic proficiency through brief instruction, allowing training resources to focus on more complex skills. German forces, with more complex weapons requiring more extensive training, faced greater challenges in rapidly training expanded forces. The tactical solution for small unit leadership emerged from combat experience. Squad leaders and other junior leaders needed to command, communicate, and observe while remaining armed. The carbine's light weight made it more practical than the Garand for personnel who needed to use binoculars, radios, and maps while staying combat ready. This solved the problem of keeping leaders effectively armed without burdening them with weapons that interfered with their leadership functions. The squad leader's role illustrated competing requirements that the carbine addressed effectively. Leaders needed to observe battlefields, direct subordinates, communicate with higher headquarters, and sometimes call for fire support, all while remaining capable of engaging enemies. The Garand's weight and bulk made these multitasking demands difficult. The carbine's lighter weight and compact size allowed leaders to perform their duties while maintaining combat capability. Urban combat solutions emerged from the carbine's handy characteristics. Its compact length made it easier to maneuver through buildings, around corners, and in confined spaces than full-length rifles. The semi-automatic fire provided adequate firepower for close-quarters combat. The lightweight reduced fatigue during extended operations in cities where soldiers moved on foot while clearing buildings and maintaining vigilance. These attributes made the carbine particularly effective in urban warfare, despite its lighter cartridge. The battle for Aachen, one of the first major urban battles fought by American forces in Germany, demonstrated the carbine's utility in cities. Infantry and support troops armed with carbines found the weapon's characteristics well suited to street fighting and building clearing. Its ability to be brought to bear quickly in sudden encounters proved valuable when fighting moved from room to room and around corners. While the cartridge's limited penetration through walls posed challenges, the carbine's other characteristics made it effective overall in urban environments. The maintenance solution reflected simple, robust design. The carbine had fewer parts than more complex weapons, reducing points of potential failure. Field stripping required no tools and could be performed quickly even by soldiers with minimal training. Parts from damaged weapons could be scavenged to repair others. This simplicity reduced logistical burden and kept weapons operational under field conditions where complex weapons might have failed. Field maintenance capability proved crucial for sustained operations. When weapons malfunctioned during combat, soldiers needed to diagnose and fix problems quickly without access to armorer support. The carbine's simple design meant that most common problems could be addressed by users with basic training. This maintained operational readiness and reduced dependence on specialized maintenance personnel who were often unavailable in forward areas. The ammunition capacity solution evolved through the war. The initial 15-round magazine provided reasonable capacity, though soldiers often wanted more. The 30-round magazine, developed for the M2 variant, addressed this by doubling capacity. The detachable magazine system allowed quick reloading compared to rifles using integral magazines or clips. This gave carbine-armed troops sustained firepower capability that enhanced their effectiveness in extended engagements. Magazine capacity represented important tactical consideration. Higher capacity reduced frequency of reloading, maintaining sustained fire during critical moments. The psychological impact of not running dry during firefights enhanced soldier confidence. However, larger magazines were heavier, more cumbersome, and potentially less reliable. The balance between capacity and practicality required careful consideration that evolved based on combat experience. The range solution balanced competing requirements. The carbine needed adequate range for defensive purposes, but not necessarily the extended range of infantry rifles. The 30 carbine cartridge provided effective range to 300 yards, covering most distances at which troops could identify and engage targets. This was sufficient for the weapon's intended roles, while allowing the lighter cartridge that enabled the overall design. The solution prioritized practical effectiveness over theoretical maximum capability. The 300-yard effective range proved adequate for most combat situations the carbine was designed for. While longer range capability would have been desirable, achieving it would have required heavier cartridges, larger weapons, and greater recoil, compromises that would have undermined the carbine's primary advantages. The Americans accepted range limitations to achieve lightweight and controllability, a trade-off that proved appropriate for the weapon's actual employment. The reliability solution emphasized robust design over sophistication. The short-stroke gas piston system was simple, reliable, and easy to maintain. The action didn't require precise timing or adjustment. The weapon functioned across wide temperature ranges and with minimal lubrication. This reliability ensured that support troops who might not maintain weapons as rigorously as dedicated infantry could still depend on their carbines when needed. Reliability under adverse conditions represented non-negotiable requirement for military weapons. Combat environments subjected weapons to mud, sand, rain, snow, temperature extremes, and rough handling. Weapons needed to function despite this abuse, ideally with minimal cleaning and maintenance. The carbine's design achieved this reliability through simplicity and robust construction. avoiding the tight tolerances and precision mechanisms that sometimes caused more sophisticated weapons to fail under field conditions. The standardization solution addressed the challenge of supporting multiple contractors producing identical weapons. Detailed specifications, inspection protocols, and quality control measures ensured interchangeability of parts across manufacturers. This allowed damaged weapons to be repaired using parts from any source, simplified logistics, and prevented manufacturer-specific maintenance issues. German multi-contractor programs sometimes struggled with interchangeability, making the American achievement particularly impressive. Interchangeability represented significant logistical advantage. When weapons were damaged, parts could be scavenged from other damaged weapons, regardless of manufacturer. Supply systems didn't need to track manufacturer-specific parts. Maintenance personnel could work on any carbine using standard procedures and parts. This standardization reduced complexity and enhanced sustainability of large-scale weapons deployment across global theaters. The doctrine solution emphasized flexibility over rigid specification. As combat experience revealed roles where the carbine excelled, official doctrine adapted to encourage employment in those roles. This flexible approach maximized the weapon's utility rather than confining it to narrow, originally conceived functions. German doctrine, more rigid, might not have adapted as effectively to evolving understanding of capabilities. Doctrinal flexibility reflected broader American military culture that valued pragmatism over ideological purity. When experience revealed that weapons performed differently than anticipated, Americans adapted doctrine to reality, rather than insisting that reality conform to doctrine. This pragmatic approach, while sometimes criticized as lacking theoretical rigor, proved effective in extracting maximum value from available resources and capabilities. The M1 Carbine's success and widespread adoption invite critical examination of its limitations, the contexts enabling its effectiveness, and broader implications for understanding weapons development and military effectiveness. The stopping power controversy persisted throughout the war and beyond. The .30 carbine cartridge, while more powerful than pistol rounds, lacked the energy of rifle cartridges. Combat reports included instances of enemy soldiers continuing to fight after hits that would have been immediately incapacitating from rifle cartridges. These concerns were partly valid. The lighter bullet with less energy had reduced wounding potential. However, they also reflected unrealistic expectations about single-shot stopping power and failure to account for factors like shot placement and adrenaline effects that applied to all cartridges. The stopping power debate revealed how subjective perceptions influenced weapons assessments. Soldiers expecting rifle-level performance judged the carbine inadequate, while those expecting pistol-level performance found it impressive. These differing expectations, shaped by prior experience and comparison standards, affected how users evaluated the weapon's actual performance. The carbine's effectiveness lay between these extremes, better than pistols but less powerful than rifles, making assessments dependent on which comparison point users emphasized. The effective range, while adequate for defensive purposes, limited offensive employment. The carbine worked well to 300 yards, but beyond that distance, accuracy and energy decreased significantly. In open terrain where engagements occurred at longer ranges, carbine-armed troops were at disadvantage compared to those with rifles. This constrained tactical flexibility in certain situations and meant that the carbine couldn't completely replace rifles, even if weight considerations might have suggested it. The range limitation became particularly apparent in certain terrain and tactical situations. In the bocage country of Normandy, where fields were small and visibility limited by hedgerows, the carbine's range proved adequate. However, in the open terrain of central France or during the advance across Germany, longer engagement ranges sometimes exposed the carbine's limitations. Units operating in these areas often wished for weapons with greater reach. The penetration limitations became apparent in urban combat. The lighter bullet lacked energy to consistently penetrate heavy walls, substantial cover, or multiple barriers. In European cities with thick masonry construction, this meant carbine fire was less effective at engaging enemies behind cover compared to rifle fire. Soldiers learned to work around this limitation, but it represented a genuine tactical constraint that affected employment. Urban warfare experiences revealed the importance of understanding weapons capabilities and limitations. Carbine-armed troops learned to engage through openings rather than attempting to shoot through walls. They learned to use volume of fire to suppress rather than relying on single shots to penetrate cover. These tactical adaptations, while effective, represented compromises necessitated by the weapon's characteristics that more powerful rifles wouldn't have required. The magazine reliability issues plagued the weapon throughout its service. The 15 and 30 round magazines were prone to feed problems if damaged, dirty or worn. The magazine lips could bend easily, causing failures to feed. Soldiers learned to carefully maintain magazines and mark problematic ones for disposal, but magazine issues remained a significant source of malfunctions. This reflected a weakness in the overall design that affected reliability, despite the weapon itself being robust. Magazine problems illustrated how weapons systems are only as reliable as their weakest components. The carbine's action was robust and reliable, but poor magazine condition could render it non-functional. This meant that soldiers needed to devote attention to magazine maintenance and management, tasks that added to their burden. German weapons generally used integral or clip-fed magazines that, while having their own drawbacks, were less prone to the damage that affected carbine magazines. The accuracy limitations stemmed from several factors. The basic sights, while adequate, weren't precision instruments. The light barrel heated quickly during rapid fire, affecting accuracy. The relatively short sight radius limited precision potential. These factors meant that the carbine was adequate for its intended ranges and purposes, but not capable of the accuracy that careful shooters could achieve with rifles. This was acceptable given the weapon's roles, but it represented inherent limitation. Accuracy requirements varied by role and situation. For support troops engaging at defensive ranges against massed targets, the carbine's accuracy proved adequate. For precision shooting at individual targets or longer ranges, the weapon's limitations became apparent. This variation in requirements meant that assessments of carbine accuracy depended on context, adequate for some purposes, insufficient for others. The cold weather performance problems emerged during winter operations. Extreme cold sometimes caused sluggish operation or failures to cycle. Lubricants could thicken, affecting the gas system's functioning. Soldiers learned to use lighter oils or operate weapons dry in extreme cold, but these adaptations required knowledge and sometimes reduced reliability. The weapon's sensitivity to cold weather represented a weakness compared to more robust bolt-action weapons. The Battle of the Bulge exposed cold weather vulnerabilities across multiple American weapon systems, not just the carbine. However, the carbine's sensitivity to temperature extremes proved greater than some other weapons. This reflected the gas-operated action's dependence on consistent gas pressure and lubrication characteristics that extreme cold affected. Soldiers who anticipated these issues and maintained their weapons accordingly generally kept them functioning, but those without proper knowledge or preparation experienced failures. The selective fire M2 variant's controllability issues reflected the basic design's lightweight. The weapon's low mass made it difficult to control during automatic fire, with significant muzzle rise and loss of accuracy after the first few rounds. The small cartridge's limited energy meant that full automatic fire was more about suppression than accurate engagement. These factors limited the M2's effectiveness in the automatic role, suggesting that the basic M1's semi-automatic only configuration was perhaps optimal for the design. The M2's automatic fire capability, while providing tactical flexibility in some situations, proved of limited value given the weapon's characteristics. The lightweight that made the carbine attractive for carry became a liability during automatic fire. Experienced soldiers learned to fire short bursts to maintain control, essentially using the M2 in semi-automatic mode most of the time. This suggested that the added complexity of selective fire provided modest benefit given the weapon's fundamental characteristics. The dependence on American industrial capacity for effectiveness must be acknowledged. The carbine succeeded partly because American logistics could supply ammunition abundantly, provide replacement weapons, and support the specialized maintenance requirements of millions of carbines. Removed from this logistical context, the weapon's effectiveness would have been reduced. Other nations without comparable industrial capacity couldn't simply adopt the carbine and expect equivalent results. The logistical infrastructure supporting the carbine was massive and sophisticated. Production facilities produced hundreds of millions of cartridges monthly. Distribution systems moved ammunition from factories to ports, across oceans, through supply depots, and forward to combat units. Maintenance systems provided parts, trained technicians, and repair facilities. This entire infrastructure represented capabilities that few nations possessed, making the carbine's success partly dependent on circumstances other militaries couldn't replicate. The training requirements, while less than for more complex weapons, still demanded instruction that some support units struggled to provide. Soldiers whose primary focus was non-combat specialties sometimes received minimal weapons training, leaving them inadequately prepared to employ carbines effectively in actual combat. The weapon's simplicity helped, but couldn't completely overcome insufficient training in some units. Training time represented limited resource that military organizations allocated across competing demands. Support troops needed training in their primary specialties: communications, maintenance, administration, medical care, which consumed most available training time. Weapons training, while important, received limited hours. The carbine's simple operation allowed achieving basic proficiency with modest time investment, but developing real skill required more extensive training that support units sometimes couldn't provide. The cost-benefit analysis deserves examination. Each carbine, while cheaper than a Garand, still represented significant manufacturing investment. The decision to arm support troops with carbines rather than pistols or no weapons multiplied costs substantially. Whether this investment provided proportional benefits is difficult to assess definitively. The carbine certainly provided capabilities that pistols didn't, but quantifying the tactical value of arming support personnel with carbines rather than allocating those resources elsewhere remains complex. Economic assessments of military equipment involve factors difficult to quantify. The carbine's tactical value included both measurable effects, enemy casualties, positions defended successfully, and intangible benefits, soldier confidence, psychological impact on enemies, flexibility in emergency situations. Comparing these benefits against costs requires judgments about relative values that admit no single correct answer. However, the Americans' decision to produce over 6 million carbines suggests that contemporary decision-makers believed the benefits justified the costs. The German fear, while genuine, should be contextualized. German engineers certainly recognized the carbine represented capabilities their forces lacked, but they also faced far more significant problems: strategic overextension, resource exhaustion, Allied industrial superiority, tactical defeats on multiple fronts. The carbine was one factor among many, and probably not the most significant. German concerns about it reflected broader recognition of American advantages, rather than the carbine being decisively important on its own. German military leadership faced cascading crises from 1943 onward that dwarfed any single Allied technological advantage. Strategic defeats at Stalingrad, Kursk, and in North Africa. Allied air superiority that disrupted production and transportation. Resource shortages affecting everything from fuel to ammunition to trained personnel. In this context, the carbine represented one more American advantage in a long list rather than the decisive factor. German concerns about it reflected how accumulated Allied advantages created situations that Germany struggled to address. In a German weapons testing facility in 1944, engineers carefully disassembled a captured M1 Carbine. The weapon had been taken from an American radio operator killed in France, and German intelligence wanted thorough analysis. As the engineers examined each component, their initial dismissiveness gave way to troubled recognition. The weapon seemed almost toy-like compared to German rifles. At 5.2 pounds, it weighed barely more than half a Kar 98K. The cartridge appeared inadequate, barely more powerful than pistol ammunition. The finish work was rough by German standards, with visible stamping marks and minimal hand fitting. Yet the weapon functioned flawlessly through testing, and reports from the front painted a concerning picture. One engineer, examining the stamped trigger housing, remarked to his colleague, "They've reduced a rifle to the complexity of a bicycle." It wasn't a compliment, but neither was it entirely a criticism. The simplicity meant that American factories were producing these weapons by the millions, while German factories struggled to meet quotas for traditionally manufactured rifles. The Americans had solved production problems by accepting standards that German engineering culture found uncomfortable. Another engineer examining the gas system noted its elegance despite apparent crudeness. This piston design is actually quite clever, he admitted. Simple, yes, but effective. And that simplicity means it will function reliably with minimal maintenance. Our troops report these weapons almost never malfunction. This reliability, combined with massive production numbers, created advantages that German forces couldn't overcome through superior individual weapon quality. The testing proceeded through various conditions. The carbine functioned in dust, mud, cold, and heat. It could be field stripped without tools and reassembled by soldiers with minimal training. The semi-automatic mechanism cycled reliably with various ammunition lots. The engineers recognized they were examining a weapon optimized not for excellence, but for adequacy at scale, and the Americans had achieved that optimization brilliantly. The technical report concluded with observations that revealed German concerns. The American carbine represents manufacturing philosophy fundamentally different from our own. They have sacrificed precision for volume, accepting standards we would consider inadequate, yet the weapon functions reliably and is produced in quantities we cannot match. More concerning, they have armed personnel we would consider non-combatants, radio operators, drivers, clerks, with weapons providing genuine combat capability. This creates defensive depth throughout American formations that complicates our tactical operations significantly. Combat reports told the story more viscerally. A German infantry captain, captured after fighting in Normandy, described his surprise at the volume of fire American units produced. "We expected to face soldiers armed like ours, a few automatic weapons and mostly bolt-action rifles. Instead, everyone seemed to have automatic or semi-automatic weapons. Even their officers and radio operators fired as fast as riflemen. We couldn't match their rate of fire." Lieutenant Hans Steiner, a platoon commander in the 352nd Infantry Division, wrote in his diary about fighting Americans near St. Lo. "Today we attempted to flank an American position. We expected their rear area to be lightly defended, perhaps some officers with pistols, maybe a few sentries. Instead we encountered sustained fire from carbines, radio operators, artillery observers, even what appeared to be cooks, all firing rapidly. We took casualties before reaching their position and had to withdraw. The Americans arm everyone, it seems, not just infantry." Another report from the Ardennes described an attempted raid on an American supply depot. The German patrol expected to find lightly armed support troops who could be quickly overwhelmed. Instead, they encountered sustained fire from multiple semi-automatic weapons. Cooks, drivers, and clerks responded with carbines, delivering fire that forced the Germans to withdraw without achieving their objective. The raid commander's report noted bitterly, "Even their support personnel fight like infantry. We cannot treat American rear areas as vulnerable targets when everyone carries effective weapons." American soldiers who carried the carbine developed varying opinions based on their experiences and expectations. Those who expected rifle-level power were often disappointed. Staff Sergeant Michael O'Brien, an infantry squad leader, traded his Garand for a carbine early in the war. "The lightweight was great for moving through hedgerows and buildings," he recalled, "but I gave it up after we hit more open country in France. When you need to reach out past 200 yards, the carbine just doesn't have the punch. I went back to the Garand and felt better about it." Conversely, Lieutenant James Harrison, a tank platoon leader, credited his carbine with saving his life when his tank was knocked out in Germany. "We bailed out under fire and had to fight our way back to friendly lines. That carbine was perfect. Light enough to run with, powerful enough to keep German heads down. It wasn't as powerful as a rifle, sure, but it was a hell of a lot better than a pistol, and I could actually carry it while moving fast. I wouldn't have wanted to carry a Garand through that." Sergeant First Class Robert Martinez, 82nd Airborne, jumped into Normandy carrying an M1A1 with its folding stock. "Every ounce mattered when you jumped," he explained. "The carbine was light enough that you could carry it, plus all your other gear without being totally exhausted before you even hit the ground. And when we were fighting in the hedgerows, that lightweight meant you could keep your weapon up and ready all day. Yeah, it didn't hit as hard as a rifle, but it hit hard enough and I could shoot it fast and accurate." The weapon's ubiquity created situations that German tactical doctrine didn't anticipate. In Italy, a German infantry company attempted to infiltrate American lines at night, planning to attack command posts and artillery positions in the rear area. The plan assumed that rear areas would be lightly defended by soldiers with minimal weapons. Instead, the infiltrators encountered carbine-armed support troops who responded immediately with effective fire. The attack dissolved in confusion as the Germans found themselves fighting armed opponents where they expected mostly unarmed personnel. Hauptmann Karl Becker, who led the failed infiltration attempt, later reflected on the experience in his post-war memoir. "We planned the attack based on our own organization, where support troops might have pistols at most. We expected to achieve surprise and overwhelm lightly armed personnel. Instead, the Americans fired back immediately with what sounded like dozens of rifles. Every position seemed to contain armed soldiers ready to fight. We realized too late that American doctrine arms everyone, not just infantry. This fundamentally changed the tactical situation and made our plan obsolete before we even made contact." German tactical manuals began acknowledging the problem. A captured document from late 1944 warned, "American rear areas cannot be treated as undefended. Support personnel carry light rifles with rapid fire capability. Plans must account for resistance from all American positions, not just infantry units. The American practice of arming all personnel creates defensive depth that must be respected in operational planning." The industrial achievement the carbine represented concerned German planners perhaps more than its tactical effectiveness. German industry, struggling under Allied bombing and resource constraints, could barely maintain production of existing weapons. The Americans had introduced an entirely new weapon, developed a new cartridge, established production across numerous contractors, and delivered over 6 million units while maintaining production of Garands, Thompson submachine guns, and other weapons. The comparative industrial capacity was sobering. Our German ordnance officer's report captured this concern. "The American carbine demonstrates production methods we cannot match. They have achieved adequate performance through simplified manufacturing that enables extraordinary volume. Our insistence on precision and traditional methods produces superior individual weapons, but at quantities insufficient for modern warfare. The Americans have chosen volume over perfection, and in war, volume often proves decisive. We must acknowledge that their pragmatic approach, while aesthetically displeasing to our engineering sensibilities, has strategic merit we cannot ignore." The weapon's influence extended beyond its direct tactical effects. American soldiers, knowing that even support personnel carried effective weapons, maintained confidence in their position's defensibility. German soldiers, recognizing that attacking American positions meant facing fire from every direction, approached attacks with increased caution. These psychological effects multiplied the carbine's physical impact, affecting tactical decisions and combat outcomes in ways difficult to quantify but nonetheless real. Private Werner Schmidt, serving with the 12th SS Panzer Division, described his first encounter with carbine-armed Americans in his diary. "We attacked what we thought was a headquarters position. We expected officers with pistols who would surrender when we got close. Instead, everyone started shooting at us with rapid-fire weapons. We lost 3 men before we even understood what was happening. The Americans don't have the distinction between soldiers and support troops that we have. Everyone shoots, everyone fights. This makes every position dangerous and every attack costlier than we anticipate." By war's end, over 6 million carbines had been produced, arming a significant percentage of American forces. German forces, having faced carbine-equipped troops across multiple theaters, had learned to respect the weapon despite its apparent lightness. Post-war interrogations of German officers consistently revealed recognition that American small arms superiority, including the widespread distribution of carbines, had contributed to tactical advantages that German forces struggled to overcome. Colonel Friedrich Weber, a German regimental commander captured in 1945, summarized German perspectives in his interrogation. "We understood American artillery was superior in quantity. We recognized their air power dominated. These were disadvantages we learned to work around through tactics and terrain. But the small arms situation, every American soldier with a semi-automatic weapon, even their support troops with those light carbines, that created constant pressure we couldn't escape. Volume of fire affects everything: attacks, defenses, morale. The Americans could sustain firefights that would have depleted our ammunition. Their soldiers fired when ours would have been conserving bullets. That accumulates over months of combat into significant advantage. The carbine's legacy extended far beyond World War II. The weapon remained in service through Korea and into Vietnam, though later conflicts exposed limitations that had been less apparent in European combat. The concept it pioneered, a lightweight, handy weapon firing an intermediate cartridge for support personnel, influenced subsequent development of personal defense weapons that military forces continue to employ today. For German engineers who examined captured carbines, the weapon represented uncomfortable truths about modern warfare. Traditional values of precision, craftsmanship, and engineering excellence, while admirable, sometimes proved less important than volume production, adequate performance, and practical utility. The Americans had created a weapon that was good enough rather than excellent, and had fielded it in quantities that made excellence irrelevant. The Germans, committed to higher standards, produced fewer weapons of greater individual quality and lost. The psychological impact of this realization affected German military thinking in the war's final years. The rushed development of weapons like the ZG-44 assault rifle reflected recognition that German doctrine and weapons needed to evolve to counter Allied advantages. However, these developments came too late and in insufficient quantities to affect outcomes. The Americans had fielded their intermediate weapon years earlier, gained experience refining tactics for its use, and produced millions while German efforts yielded only hundreds of thousands. In captured correspondence, one German officer wrote to a colleague about American weapons. "They have given rifles to everyone. Not great rifles perhaps, but adequate ones, and so many that it doesn't matter. We remained committed to the perfect rifle carried by some, while they armed everyone with good enough rifles. In war, volume sometimes defeats quality, and we are learning that lesson painfully." The M1 Carbine story illustrates how technological innovation, industrial capacity, and tactical flexibility combine to create military advantages. The weapon itself was not extraordinarily powerful or sophisticated. Its cartridge was modest, its range limited, its stopping power questioned. Yet it filled roles that other weapons couldn't, provided capabilities that support troops had previously lacked, and did so in quantities that made its individual limitations irrelevant. German engineers feared the carbine not because individual weapons were fearsome, but because millions of them armed American forces in ways German forces couldn't match. The weapon represented an approach to warfare, industrial, pragmatic, flexible, that Germany's more traditional military culture struggled to counter. In examining the carbine, German engineers saw not just a weapon, but a mirror, reflecting their own disadvantages, and the reflection was deeply troubling. The carbine armed officers directing troops, radio men calling for support, tank crews fighting dismounted, paratroopers dropping behind enemy lines, drivers defending convoys, artillerymen protecting their pieces, and countless others whose primary duties weren't infantry combat, but who might face combat situations. In doing so, it created depth of defensive capability and breadth of armed resistance that German tactical doctrine hadn't anticipated and German forces couldn't overcome. When German soldiers spoke of being outgunned by Americans, they didn't necessarily mean that American weapons were more powerful, though sometimes they were. They meant that Americans brought more guns to every fight, that even support personnel returned fire effectively, that every position seemed to bristle with weapons, that the volume of fire made advancing difficult and defending costly. The M1 Carbine, carried by millions, contributed substantially to this reality. The weapon's greatest achievement wasn't technical sophistication or tactical brilliance, it was practical utility at massive scale, being adequate enough for diverse roles, simple enough for rapid production, light enough for universal carrying, and effective enough to matter, all delivered in quantities that made it omnipresent. That combination, more than any individual characteristic, explains why German engineers studied captured carbines with growing concern, recognizing in this unassuming weapon a demonstration of American advantages they could not match.